Dear friends, once again, good afternoon to everybody. We are meeting in third lecture. Prior to this, we studied the types of communication system, where we have studied four types of communication system. One is analog communication system, second one is digital communication system, third one is simplex system, and today we are going to study a duplex type of communication system. Duplex type of communication system is a type of electronic communication which is used in telex and telephone department to transmit the signal, to transmit the message, or to transmit the information from one subscriber to the other subscriber at a time through the same transmission line. Thus we can say duplex type of communication system is a communication system in which two signals are transmitted through the same line in both the direction. That is the reason why we can say duplex system is a bi-way communication system. For example, telephone communication is a very good example of duplex system, where two subscribers are going to speak with each other through the same transmission line at a time. Hence, it is to be recognized as a duplex type of communication system. Thus, we can say in duplex system, two messages can be transmitted in each direction over a single transmission line. In this particular system, a station can transmit and receive the message simultaneously over the line. This means that if suppose there are two stations which are communicating with each other, then out of two stations, either can going to act as a transmitter as well as receiver. In consequence, we can say both the stations are going to act as a transmitter and both the stations are going to act as a receiver. That means both the stations transmit the signal and also both the stations are going to receive the signal. This means that when one station is going to act as a transmitter, then other station is going to act as a receiver, and when other station is going to act as a transmitter, the first station is going to act as a receiver. Such a type of the communication system, if it is existing, then that type of system we can call it as it is the duplex type of communication system. There are two types of duplex communication systems. One is bridge duplex system and another one is differential duplex system. The duplex system that works on potential balanced bridge is known as bridge duplex system, and the duplex communication system that works on current balance is known as differential duplex system. In opposition method of differential duplex, batteries of two stations are opposite to each other, and in combinational method, batteries are joined in series. A specific property of duplex communication system is that if suppose two stations are involved in the communication, let me consider the station A and station B. If suppose station A is transmitting the signal, then B is going to receive the signal. When station B transmits the signal, then station A is going to receive the signal. Both, that means station A as well as station B, are going to transmit the signal. Both, that is station A as well as station B, both are going to act as receiving the signal. So this is the peculiar property of the duplex type of communication system. The bridge duplex systems are useful in a long distance telegraphy circuits having large capacitor with a high working speed than that of differential duplex system. That means bridge duplex systems are used for long distance communication with a high speed with large capacity. Bridge duplex system current is regulated, which is independent of transmitting station. This helps to carry sensitive adjustment in relay. Because of high resistance of the bridge, the inductive disturbance and earth current doesn't felt. In differential duplex, relay coil are connected in series, increasing inductance to reduce the speed. Means that the differential duplex system has less speed than that of the bridge duplex system from the point of view of transmission and reception of the signal is considered. In bridge duplex system, inductance has no effect. In short, we can say a duplex type of communication system is used to transmit and receive the signal in both the direction. Friends, with this particular type of communication system, we can say that we completed 4 types of communication system. That is analog communication system, digital communication system, simplex type of communication system, and also the duplex type of communication system. To proceed further, we have to move for to deal with the electromagnetic spectrum. In the aspect of electronic communication, when transmitter transmit the radio frequency signal in a radio frequency range to the transmitting antenna, and transmitting antenna converts these radio frequencies into its corresponding electromagnetic radiations, and these radiations are going to carry the information along with them through the space, to which we can call it as the channel, and then it reaches to the receiving antenna at the receiver. During this particular aspect, the radio frequency signal which is used for radio communication is going to exist in the form of a spectrum, and that spectrum is known as electromagnetic spectrum. So we are going to study what is that type of spectrum and what are the different types of spectrum that possesses different type of frequency range, what kind of wavelength those possesses, in which class does they going to exist, what are their propagation characteristics, and the purpose for which those type of radio frequency is being used. In a peculiar slide, we can say the radio communication uses the range of radio communication uses wide range of carrier frequencies for different types of services. The classification of electromagnetic spectrum used for radio communication is presented in this particular table that represents the propagation characteristics and type of services also. Thus, if you go through the table, we are going to understood almost all the wide ranges of radio frequency which are used for the different purposes with the different class, with the different frequency ranges, with unique propagation characteristics. With this particular aspect, the table includes the carrier frequency, its wavelength, then class, propagation characteristics, and also the service, that means the purpose for which those are being used. Friends, the first carrier frequency in a radio frequency range. The meaning of radio frequency is the frequency range having above 20 kilohertz is known as a radio frequency. By considering that particular basic concept of radio frequency, the first frequency range represented here is 10 to 30 kilohertz. This frequency range possesses the wavelength that is 3 into 10 raised to 4 meter. This frequency range, we can call it as, it is a very low frequency range. These are used in a daytime throughout the year, and they are going to provide a service for long distance communication, especially for the point to point communication. Means very sharp from one point to the another point, that covers a long distance, which are available during the daytime throughout the year, that belongs to very low frequency class, having the frequency range 10 to 30 kilohertz. The next carrier frequency range is 30 to 300 kilohertz, which has the wavelength 10 to 4 to 10 to 3 meter. And this is known as low frequency range. And this range of radio waves are available during the night time. They provide service again for point to point communication and also in Navy. That means in Navy, for the purpose of communication, the frequency range used will be 30 to 300 kilohertz. Next frequency range is 300 kilohertz to 3000 kilohertz, having the wavelength 10 to 3 to 10 to 2 meter. And this range of frequency is known as medium frequency range. And this frequency is used for the ionospheric propagation. Means especially far away above the atmosphere, inner space. If the frequency range that reaches is in between 300 to 3000. 3000 means 3 megahertz. And these are used for the purpose of broadcasting. Broadcasting means maybe it is a television broadcasting, or maybe it is a radio broadcasting. The frequency range is 300 to 3000 kilohertz, and also it is used ship to shore, means from ship to landline communication. Next frequency range is 3 megahertz to 30 megahertz with the wavelength 100 meter to 10 meter. This frequency range is referred as the high frequency range, which is also suitable again for ionospheric propagation. And this range of frequency is used for telephone communication and also in the telegraph field. Next range of frequency is 30 to 300 megahertz with the wavelength 10 to 1 meter. This frequency range is known as a very high frequency range, and that can be used for line of sight communication. Can also be used for a tropospheric communication. These can be used for radar communication, television communication, facsimile communication purpose. Facsimile means for fax purpose, and they are used for short distance communication. Next frequency range is 300 to 3000 megahertz with the wavelength 1 to 0.1 meter. This range of frequency is called as ultra high frequency, which are suitably used again for line of sight as well as tropospheric communication. These are best suitable again for facsimile, that is for fax purpose, and also for the television communication. The last carrier frequency range is 3000 to 30,000 megahertz with the least smallest wavelength, that is 0.1 to 0.01 meter, is known as super high frequency. That also used for line of sight communication, especially those are used in radar as well as navy for the purpose of transmitting the signal from transmitter toward the receiver. From this particular table we can say whatever the frequency ranges which we have discussed are only the frequency range, those are used for the purpose of communication. Apart from these, there are in electromagnetic spectra, there are many type of waves which are going to be existing. Just we have studied from very low frequency up to super high frequency. Apart from that, it may carry X-rays, it may carry gamma rays, it may carry cosmic rays, it may carry ultraviolet radiations. So all such different types of radiations are also present. Combinedly, it is known as electromagnetic spectra, but those radiations are not used for the purpose of communication, especially for the electronic communication. And in this particular table, only we have studied the frequency ranges, the range of wavelength, which are used only for the purpose of electronic communication. So the range of frequency from 10 kilohertz up to 30,000 megahertz, having the wavelength 3 into 10 raised to 4 meter up to 0.01 meter are used for the purpose of electromagnetic communication. That range of frequency from the point of view of electronic communication, we can refer it as the electromagnetic spectrum. After knowing the range of electromagnetic spectra, we will proceed further to deal with bandwidth requirement. Friends, whenever the signal is transmitted from the transmitter, it is going to be transmitted within allotted bandwidth, so that the design of transmitter, the design of receiver, the design of several stages which are required in transmitter as well as in a receiver are going to be designed depends upon the bandwidth through which the carrier frequency signal is going to be gets transmitted. That means once we know the range of carrier frequency, within which the signal is going to be gets transmitted, then it becomes very easy to transmit and receive the signal, and also to design the electronic circuitry necessary in the transmitter as well as in the receiver very easy. And that is the reason why bandwidth is required in the electronic communication system. Friends, we have already studied in B.Sc part 1 or we have studied in B.Sc part 2 the meaning of bandwidth. Bandwidth is nothing but the difference between upper cutoff frequency and the lower cutoff frequency within which the signal is going to be transmitted and it is going to be received. Or we can say it is a difference between upper 3 decibel frequency or lower 3 decibel frequency, to which we can call it as it is bandwidth. For different type of communication, for radio communication, for satellite communication, for internet communication, for television communication, for telephone communication, required bandwidth are different. So that intermixing of the signals is also going to be gets avoided. And that's why the bandwidth has much more importance in the electronic communication system. Hence, we are going to study that particular concept in our first topic, known as the fundamentals of communication system. Friends, throughout this particular topic, try to remember that almost all we are introducing the electronic communication system, and along with that very fundamental quantities which are required for the purpose of communication. And from that point of view, we are introducing now the bandwidth requirement, or we can say the concept of bandwidth. For a given transmitter, bandwidth requirement depends upon maximum modulating frequency and the nature of the modulation. As we have introduced at the beginning or prior to this, in transmitter, maybe it is analog communication, or maybe it is a digital communication, modulation takes place. Without modulation, no information, no message, no signal is going to be transmitted. From that point of view, to build a transmitter, to construct a transmitter, the bandwidth is going to be decided, and it is going to depend upon modulating frequency. Modulating frequency means the signal to be transmitted. What type of signal we are going to transmit? Whether the signal is in audio frequency range, whether the signal is in the radio frequency range, that is going to decide. And also the nature of modulation means what type of modulation we are using in the transmitter. Whether it is analog modulation, whether it is a digital modulation. In analog modulation, which method we are going to prefer. In digital modulation, what kind of methods we are going to prefer. All those are going to decide to make the requirement of bandwidth for the transmitter. Modulating voltage is a signal sinusoidal voltage that possesses the frequency. That frequency is known as the modulating frequency. Means the signal to be transmitted is in the form of sinusoidal voltage form. How it is possible? Friends, while introducing the communication system, when we have studied the source or information, there we have studied that any physical quantity, if it is to be transmitted, it is to be converted into electrical signal. And that electrical signal is in the form of sinusoidal voltage variation. And that signal we can call it as it is a modulating signal. In practice, several sinusoidal voltages with the frequencies extending over the frequency band. Means depends upon type of physical quantity to be transmitted. There are different types of sinusoidal voltages with having different frequencies which are going to be located within the frequency spectrum. For example, the electrical signal produced by the speech. Electrical signal produced by the speech means when we are speaking by making use of the mic convert that acoustic signal or sound signal into electrical signal. So that signal we can call it as the electrical signal produced by the speech. Or the music instruments means the signal produced by the musical instruments. Extends over audio frequency range of 20 Hz to 20 kHz. Here we have to focus on the frequency range, that is 20 Hz to 20 kHz, which is the audio frequency range. Whether the person is going to speak or any musical instruments that generates the frequency which we are capable to listen, that possesses the frequency range of 20 Hz to 20 kHz. And this is the bandwidth for audio frequency range. Next one is this frequency range is very large, maybe going to west in certain cases. In practice, 0 to 3 kHz for radio telephony that uses SSB. SSB means single sideband, that makes use of single sideband. With AM is only 3 kHz per channel. So in practice 0 to 3 kHz for telegraph. So telegraph system was priorly used, now it is out of use. So that uses the frequency range between 0 to 3 kHz. So telegraph is the kind of a situations where the persons are using that particular facility to inform from one place to the another place. That makes use of the frequency band of 0 to 3 kHz. The AM broadcasting makes use of the frequency of 0 to 5 kHz. For FM broadcasting, the frequency range used is 0 to 15 kilohertz. FM means frequency modulation, AM means amplitude modulation. The band required for radio telephony that uses SSB means single sideband with amplitude modulation is only 3 kilohertz per channel. So what all these aspects suggest? Actual audio frequency range is 20 Hz to 20 kHz. Depends upon type of modulation used. Whether it is the AM, whether it is the FM, depends on type of application for the purpose for which it is being used. The bandwidth is going to vary. FM produces ideally infinite sidebands, but significant sideband extends only up to the fifth order, with maximum modulating frequency of 25 kilohertz. So especially when you speak about frequency modulation, which is going to generate the infinite sidebands. Obviously, amplitude modulation, concept of SSB, concept of frequency modulation, we are going to study in the next topic. But as far as bandwidth is being considered, when we are going to deal with the FM, definitely it produces infinite sidebands, but significant sidebands extends only of the fifth order, with maximum modulating frequency 25 kHz. Total bandwidth required per FM channel is 2 into 5 into 15, that is equal to 150 kilohertz. Thus, the bandwidth of modulated transmission depends on the bandwidth of modulating signal itself. As we already studied, bandwidth is going to depend upon the modulating signal itself. If the modulating signal is a sinusoidal, bandwidth occupied is equal to the frequency range of lowest and highest sine wave signal. Means upper cutoff frequency as well as the lower cutoff frequency is going to decide the bandwidth of the modulating signal. If the modulating signal is not a sine wave, then one can make use of the Fourier analysis, and by using that one can determine the frequency occupied. So meaning thereby, for sine wave easily one can decide the bandwidth. If suppose the signal is not present in the form of sine wave, one can make use of the Fourier analysis technique, and by using that one can decide the bandwidth which is required to design the transmitter as well as the receiver. This is how one can focus or one can study the requirement of the bandwidth. So friends, today we will stop here only. The rest of the aspects we are going to study in tomorrow's lecture.